Hey guys, so welcome to the BMC Midterm Review for STP 2017. We're going to be going through the review guide to get you guys ready for your midterm exam, so you can feel free to follow along with your exam review. Remember, at any time you can access the timestamps at the bottom of the video if you want to jump to a specific problem, but let's go ahead and get started with our first problem. So the first section here I'm going to call Topic 1. Okay, so in topic 1, we have some laws of exponents going on. So we're going to go ahead and review those as we go through these 4 problems. So here's the first problem. Okay, so for this one, we're just going to use the power to the power rule. So that power of 3 outside is going to be applied to the -3, which has a power of 1. The 4 and the 2, right? So I'm taking this guy here and sort of distributing it almost to each of these exponents here, remembering that there's a 1 here. So in the end, I would have this. Notice how I put the 3 in or the -3 in parentheses, right? 4 times 3 is 12, and then 2 times 3 is 6. So the reason I put that -3 in parentheses is because I want to remember that I'm doing -3 times -3 times -3, right? Which would be important, especially if if it was an even power. So here, I'm going to get -3 times -3 times -3 is -27, x to the 12th, y to the 6th. Okay, so there's our first problem. And let's go ahead and put problem B on the same page here. So now we have sort of 2 things being multiplied to each other. 2 groups. Okay, so for this one, you want to make sure that you remember that when you're multiplying like bases, you add the exponents. So first of all, I can go ahead and multiply the 9 and the negative symbol that's in front of that x to give me -9, right? We can do the numbers first. Then the x's, those are like bases, so I'm going to add the 1/4 and the -3/4. So I could even do a little side problem. 1/4 plus -3/4, that's the same thing as -3/4, is -2/4, which is equivalent to -1/2. So the x has a power of -1/2. And then I have y to the -3 plus y to the -3 times y to the +3. So if I add those, -3 plus 3 is 0. So y to the 0, and then anything to the power of 0, kind of excluding the case of 0 to the 0. We're not going to get into that, but I would get -9 over x to the 1/2, and then y to the 0 is 1. Okay, so I would just have this as my result here. Again, the exponent of x has become positive because I've moved it to the bottom, so this would be my final answer. Okay, let's keep going here. Let's move on to question C. So question C looks like the following. Okay, very similar to the first problem. I'm going to apply this power of -2 to the 4 and to the power of 1, but not to the 3 because the 3 is not inside of these parentheses. So the 3 is just going to kind of hang outside there. I have 2 to the -2. Again, notice how I put that in parentheses. X to the -8, 4 times -2. So now we have 3 over 2 to the +2, x to the +8, and then we know that 2 squared is 4. So this would be my final answer for part C. Okay? All right, question D. 20x to the 2nd, y to the 1/5, all over 5x to the -1/5. So first of all, notice that there's only a y variable up top, so that one's going to stay by itself, and it already has a positive exponent of 1/5, so it's going to stay up top. 20 divided by 5 is 4. And then here, when I'm looking at the x's, because I'm dividing everything, I want to subtract 2 and -1/5. So again, if we kind of do a little side problem down here, 2 minus -1/5, right? You have a double negative, so it becomes a 2 plus 1/5. So 2 I can write as 10 over 5 plus 1 over 5. So what I did there is I multiplied that 2 by 5 over 5 to have it a common denominator so I can actually add these fractions, right? So then I have 11/5. So that's the exponent of the x, and then like we said, there's no other y's. So that guy just stays there. So there's our final answer for part D, or question D. Okay. All right, moving right along to topic 2. So topic 2, we are looking at radicals, right? So the first one says this, the square root of negative 36. Immediately we know, or we should know, that this is an imaginary number. It gives an imaginary result, i.e. it is not real, right? So I can't do anything with that. If we go a little bit further, if you're familiar with this, I could actually write this as 6i, where I is equal to the square root of negative 1. Okay, but we're not going to get into that. For our purposes, we're just going to say imaginary, i.e. not a real number. Okay, so let's keep going to question B. So question B, we have the square root of 10 times the square root of 20. So for this guy, we're going to use this law that if you have the square root of x times the square root of y, that's equivalent to the square root of x times y, all in the same root, right? So this is equal to the square root of 200. And then what I'm going to do is break down 200 into the square root of 100 times 2. Now, why did I choose 100? Because 100 is a perfect square. And using that law down here, sort of in reverse, and breaking it up again, I have this, and then 10 root 2, right? Something else I could have done is I could have written the square root of 10 as the square root of 2 times the square root of 5, the square root of 20 as the square root of 4 times the square root of 5, and there I would have been able to do some simplification and get down to the same value here. And I think if you look at the answer key, that's actually how I did it on that one. So this is kind of a second way that you could do that, just as kind of another resource or method for solving that one there. Okay. And let's keep going. So now we are on topic 3. So topic 3, we're starting to get into rational expressions. So question A, we have 3 over x plus 2 plus 3 over x minus 2. So first of all, same idea. I don't have a common denominator and I'm adding. Remember, multiplying and dividing, that's not required, but for addition and subtraction of fractions, or in this case, rational expressions, right, fractions with polynomials, I still need to have a common denominator. So you should see that both of these have a unique denominator, so my LCD is just going to be x plus 2, x minus 2. There's no sort of factoring that I need to do, right? Everything's in its prime factorization, so I can very easily see, oh, okay, this has an x plus 2, this has an x minus 2, so I have to combine them, right? There's not even any sharing amongst the denominators there. So the second fraction over here, I'm going to multiply by x plus 2 over x plus 2, and I'm going to put this guy in parentheses to remind me that that is with itself, it's grouped together, right? So that I have a binomial times a binomial. I need to remember that. And then this fraction over here was missing the x minus 2, so I multiplied by that in the top and the bottom. So right here, I'm going to distribute the 3 for both of these. So if I do that, I get 3x minus 6 over x minus 2, x plus 2, and then plus 3x plus 6 over x minus 2, x plus 2. And then since I have a common denominator, I can now add everything in the numerators. I'd see that the 6 and the negative 6 cancel. The 3x and the 3x combine, and I can write everything as one denominator. I could have done that in the previous step too, since I now have the common denominator. So that would be my final answer for question A. Okay. Let's go on to question B. So question B. Okay. So again, I need to find an LCD, or a least common denominator, for this problem. To start out, I'm going to note that this quadratic can be factored as x minus 6, x minus 2, right? So two numbers that multiply to multiply to 12 but add to negative 8, negative 6 and negative 2. So now if I compare this denominator with this one, I see that there's a unique x minus 6, so I'm going to write that down here, and then they share an x minus 2. So in all I have x minus 6, x minus 2 as my LCD, which means that this one over here, this fraction, I need to multiply by the missing x minus 6 over x minus 6, right? So I'm going to have to distribute that 3. So now I have a x minus 2. And this time I am just going to go ahead and write the denominator once. That was the point of finding the LCD. But here I need to be very careful because this is a minus 3, right? So if this 3 is being applied to both of these, it's actually a minus 3. So I have negative 3 times x and negative 3 times negative 6. So I get negative 3x plus 18. Okay, so that negative sign is being applied to that 3. So when I distribute the 3, I got to apply the negative sign as well. So in the end, I have x and negative 3x is negative 2x, and then negative 2 plus 18 is positive 16, all over x minus 6, x minus 2. Now, a lot of times for these problems, what you want to do is when you get to the end, you want to factor anything in the numerator you can, just to see. Sometimes there are cases where you can cancel some stuff. If I took out a 2 or a negative 2, there would be nothing up top. I'd either get x minus 8 or negative x plus 8. Nothing would cancel at the bottom. So I'm just going to go ahead and leave that as my final answer. Also notice I'm leaving my denominator as my final, or in factored form, just to kind of remind me, oh, what was my LCD, just to go back and look at that, and I can refresh myself on the steps that I took. Okay, so let's look at letter C. Okay, so letter C, we have a division problem. So remember, for multiplication and division, you do not need a common denominator. So that'll help us save some time. But what I do want to do is factor everything that I can, right? That's always a good first step. Okay. And in addition to that, in the same step, dividing by a fraction is the same thing as multiplying by that same fraction's reciprocal, right? So if I take x squared minus 16 and x squared plus 5x plus 4, I do the reciprocal. That's what I'm doing here. But in the same step, I'm factoring. So this is being moved to the top, which is going here. And then that's also a difference of squares. So that would become x minus 4x plus 4. And then if I factor x squared plus 5x plus 4, again, that gets moved to the bottom because I'm multiplying by the reciprocal. And the factorization of that is x plus 4 and plus 1. Okay, so now I can look at this and see, is there anything I can cancel with this? So I see an x minus 4 pair, I see an x plus 4 pair, and it looks like that is it. Yep. So I'm left with a 3 x plus 4 over x plus 1. Okay, so I'm going to leave my answer like that. You could have also distributed the 3. You know, this kind of last step is, there's kind of some leeway as far as how you can write it. I think in the answer key I wrote 3x plus 12. You could have also done that, but this is fine too. Okay, so there's question C. And then our final question in this topic of rational expressions, this one's a little bit longer, is a complex fraction. So a complex fraction is when you have a fraction within fractions, right? And it's easy to remember because it looks very complicated, hence the name complex. So to save some time here, usually we could do a subtraction problem, an addition problem, and then deal with the overall fraction, but that is a lot of work. So what I'm going to do instead is use my knowledge of the least common denominator for these 4 fractions, where I could also write 3 as 3 over 1, to kind of simplify my life a little bit. So if I compare x minus 2, 4, 1, and x, all of those subfractions denominators, if I look at this guy, this guy, this guy, and this guy, and I try and find the LCD, what I should see is that all of these are unique, right? So I'm going to have 4 times x times x minus 2, okay? So what I'm going to do is take all those and make that my LCD, and then I'm going to try and eliminate all of the fractions so that I'm actually left with just one fraction, okay? So again, I'm going to take 4, let me get my pen here, 4x x minus 2. So that is my LCD. So I'm going to multiply that and the top and bottom of this overall fraction, 4x times x minus 2 over 1, all of this times 4x times x minus 2 over 1, right? So I'm taking this guy, distributing it to these fractions, and then the same thing up here, okay? So I'm going to finish this problem on the next page, but if we look here, what we have going on is here the x minus 2's will cancel, so I'll be left with 4x times 1, which is 4x. Here, I'll have the 4's cancel, I'll be left with minus 1x times x minus 2. Here, nothing will cancel, so I'll have 3 times 4x times x minus 2. And here, the x's will cancel, I'll be left with 4 and x minus 2. So if that's a lot of words for you, which it probably is just the way I said it, hopefully that was clear. But if it's not, just go through and do all the multiplication separately and see how all of these things have something cancel except for this guy here, right? So my next phase of the problem, so we'll put 3 dots, so we're continuing this here, is again, that first fraction will have 4x left over, right? Then we will have, let's see, 4x, and I want to make sure I get it right, 4x, and then the 4's cancel, so I have x minus 2, and that was a minus, so minus 4x minus 2 all over, that one nothing cancels, so here I'm at this step now, so 3 times 4 is 12, x minus 2, so 12x x minus 2, and then finally that last fraction, the x's cancel, so I'll have plus 4 x minus 2. And I think I may have messed up on that first one, or that second one. So let's just go through and recap this, right? Because this is kind of a tedious part. X minus 2's cancel, I'm left with 4x. Let's check that. Yep, got the 4x. Next step, 4's cancel, so I should have minus x minus 2. And I think that's the one, yep. So this should be an x. It's a good thing we went back and checked, right? So we got that one. Next one we have is 3 times 4 is 12, x minus 2. 12x x minus 2, yep. And then lastly, the x's cancel, so I have 4x minus 2, 4x minus 2. Good, there we go. Okay. So finally, now I can distribute this up top here. So I'll have 4x minus x squared plus 2x, watch that double negative, all over, and then I'm going to distribute these as well. So 12x squared minus 24x plus 4x minus 8. Okay. Okay, so let's keep going here. Just bear with me. This problem is pretty long. I'm going to write the top in standard form, combining that 4x and 2x. And then I'm going to have this guy down here, combining negative 24x and positive 4x is negative 20x minus 8. Okay. Now, I'm going to see if there's anything I can simplify here. So the first thing I'm going to take out of the top is I'm actually going to take out a, let's see, an x. Let's take out a negative x, so x minus 6. And that'll give me the top. And then the bottom, there is a 4 in common, right? So if I take out a 4, I get 3x squared minus 5x minus 2, right? So what we want to see here is there anything, if I were to factor this bottom here, that's going to cancel with the top, right? And I'm going to just save some time here and help you out a little bit. If you do factoring by grouping on this guy, in fact, you will see that there is nothing that shows up here that will cancel with the top. If you factor this, you actually end up getting 3x plus 1 times x minus 2. I'll let you do that just kind of as some extra practice with grouping, but nothing would cancel. So again, just to save some time here, this is going to be my final answer. I could have also left it in the previous state before I factored out that negative x in the 4, but hopefully you get the point there. So that was a little bit longer of a problem, but that's okay. It was good practice with watching our signs and combining like terms and all that good stuff. Okay, so let's go ahead and move on to topic 4. Okay, so topic 4, we have some actually more combining like terms. So that was kind of a good warm up. So here's letter A. Okay. So for this one, the first thing I'm going to do is distribute the negative 1. So I have it actually written like this. I always like to do that just to make sure I get all those negatives taken care of. So that becomes a negative 8x squared, that becomes a negative 3x, and that becomes a positive 8, right? So I can see that the negative 8 and the positive 8 are going to cancel. The 5x squared and the negative 8x squared is going to become negative 3x squared, and then the 8x minus 3x is going to be 5x. So that would be my final answer for letter A. And now we have letter B. So we got to be careful with this one. We got a lot of parentheses and brackets going on. Okay. So order of operations, I'm going to handle everything inside here first. Work my way inside out. Okay. And then I can combine like terms. The 6x and the negative 9x is a negative 3x. The negative 9 and the positive 9 cancel. So 2 times negative 3x is negative 6x. So that is my final result. Okay. All right, let's keep going. So question C. All right, so this one we got a good old-fashioned multiplication problem. I'm going to use the box method for this just because I like to keep my work organized sort of in a box. If you like to use the FOIL method or some other method to keep your work organized, feel free to do so, but this is what I like to do. Remember, it doesn't matter if you put the first one on the side or on the top. Okay, so now I'm going to fill in all these boxes by multiplying. So 4x times 2x squared is 8x cubed. 3x times 4x is 12x, positive 12x. Negative 5 times 4x is negative 20x. Negative 1 times 2x squared is negative 2x squared. Negative 1 times 3x is negative 3x. Negative 1 times negative 5 is positive 5. And then I have these like terms and these like terms. And I missed I should have a squared on it. Okay, so if I do all of that and I combine those like terms, 12x squared minus 2x squared is 10x squared. Negative 20x plus negative 3x is negative 23x. And then we have the plus 5. So that is my final result for that one. Okay. All right, let's keep going. So we are on question D now. So question D. Okay, so this is also a multiplication problem. So biggest thing you have to be careful with is this is not equal to this, or any variation of that, right? That is not right. This is really equal to, if you write it all out, this. That's the most common mistake. Okay, so now I'm going to use the box method again. Again, use whatever works for you. Okay, fill this in real quick. minus 10x minus 10x plus 25. I have like terms here, so in the end I have 4x squared minus 20x plus 25. Okay. And there is one thing, if you look up here, that I need to go back and fix. These had y's on them. Whoops, this had a y on it, right? So in here, this should be 10xy and 10xy and negative 20xy. Okay, so I went a little bit too fast there, so you just got to be careful. You can see even I make a mistake, so you got to be careful. And then also, this 25 should have a y squared, again, because there's a negative 5y times a negative 5y. So down here, I'm going to add the y squared. So we got 4x squared minus 20xy plus 25y squared. There we go. Okay. All right, let's move on to topic 5, our final topic. Okay. So topic 5, we have factoring. So question A, x squared plus 36. Okay, so this is a sum of squares, right? Which we should know is prime, right? There are no, if it bothers you as to why that's true, remember you can write this like this. So try and find two numbers and multiply 36 and add to 0. You're going to be taking quite a bit of time because you will never find those numbers. So that is a prime factorization already, or it's in its prime form already. Okay. All right, here is the next one. So this one, I should recognize that there is a 6x to the fourth as a GCF, right? They share 4 x's and a common factor of 6. So if I take those out, I get 5x plus 1. Okay, remember you can always distribute that back in to see, what do I get back the original answer or the original problem that I started with, okay? So there's that one. All right, and we are on C. Okay, this is a pretty common question. They try and trick students sometimes by putting a difference of squares in terms of a power of 4, as well as switching where the number and variable is. So this is actually, if this helps you, so that you can see the difference of squares, right? There's your difference of squares, 6 squared minus x squared squared. So I have a squares that I'm taking the difference of. So this is a difference of squares, and it's just that the pattern is going to be backwards. So I'm going to have minus 6 minus x squared and 6 plus x squared. Okay. So following the same general pattern as a difference of squares, it's just now I have an x to the fourth. So my answer has an x squared, 2x squareds in it. Okay. All right, letter D. So letter D, we have x squared minus x minus 20. So two numbers that multiply to negative 20 and add to negative 1, that middle coefficient, right? So that would be negative 5 and 4. Okay. Don't worry if you don't get them right away, especially if the numbers are kind of big. Sometimes it just takes some trial and error, but as you practice more and more, you'll get better at them. Okay, finding those factors you need. Okay. All right, letter E, almost done here. Letter E, got this one and one more. All right, so if you look at this one, and that is actually a 9. So if you look at this one, first of all, I have a cubic, right? So for cubics, generally when you see 4 terms like this, you're going to use factoring by grouping. So I'm just going to change this slightly and make that middle minus a plus negative 3x plus 9, right? We talked about in class why that's a good idea to do, just so you don't mess up the problem. Okay, so I'm going to group these first two and these last two terms, find the GCF of these first two, which would be 2x squared, so I'm left with x minus 3. So I want to get that x minus 3 repeated, which means in the second grouping, I'm going to take out a negative 3, right? Because now, since they have an x minus 3 in common, I factored that out itself, leaving me with 2x squared minus 3, right? next to that, okay? So here would be my final answer. And again, I can go back and multiply these and make sure that I get that original problem that I started with if I have time to do that, okay? All right, and then finally, question F, 4x squared plus 8x minus 5. Okay, so again, it's always a good idea to see if you can take out a GCF from any of the terms that are given to you. In this case, I can't. It is true that 4 and 8 share the common factor of 4 as well as x, but negative 5 does not have either of those. So I need to revert to factoring by grouping. So the process goes like this. I multiply these two numbers, and now I find two numbers that multiply to negative 20 and add to 8. Okay, so if you do that, that's an 8 here. If you do that, you should see that it is 10 times negative 2 and 10 plus negative 2, okay, or 10 minus 2. Okay, so that works out. So now on the next line, I'm going to copy the first term. I'm going to split up the 8x in the middle there into 10x minus 2x, those factors I just found, and then I copy the negative 5 there. So look how this is exactly the same as the problem I started with. It's just that 10x and negative 2x have split up the 8x there, right? Okay. So again, I'm going to get my pen here. I'm going to split this up using an addition symbol. Factor out the GCF of these first two guys, which would be 2x. So I'm left with 2x plus 5. I need that 2x plus 5 repeated, so I'm going to take out a negative 1. Okay. So in all I have, and actually let's just write, let's see if I can fit it here. 2x minus 1, 2x plus 5. There we go. Okay, so there is my final answer for question F and my final answer for this review. So go back through these problems. Remember, you can jump to specific problems using the timestamps at the bottom of the video. Subscribe to the YouTube page so you can get updates on when new videos are posted. Hopefully this was helpful to you guys, and good luck on your midterm exam. Thanks for watching.